Okay, looks like everything is working. Sorry about the delay, and let's begin. Okay, so as we've stated multiple times before, I'm trying to create an AI system that allows us to create pretty much an alternative reality, aka a living world, for an MMO. While we are working on the arena mode first, now that we have pretty much the basic skills of the battle mage done, we want to add a little bit of an AI system in there, so you have pretty much somebody to fight with as for the test dummy, since multiplayer is still not implemented yet, and it probably won't be until we completely switch over all the code to C++. So pretty much the idea behind the AI system that you would need for the MMO is that you need the ability for functions to be able to be converted into words and words to be able to convert to functions. You need that two-way linkability. And the way I thought of implementing it was in the shortest way possible to explain would probably be that in a game, every time you enter an action or something affects a character, the character does an animation. And these animations are oftentimes um, placed in an animation state machine. So overall, the character, every time it's in game, whenever there's a visual change, it pretty much changes states between various different animations. Okay? And when it does that, I've pretty much designed so that it triggers the functionality related to the action every time it enters the corresponding state machine state. And that's pretty much the overall gist of it. Now, let's get into much more of the specifics. Basically, the way the system works is pretty much there's two loops effectively. Or you could consider it two paths because one of them is not really a complete loop. You have this top part over here where you see the textbook text input, and you can see this flow chart going around and around and around all the way to here, and then down to here to the reset animation state. So this path right here is one path, and there's another path over here starting from the incoming attack, and then going back to here, and that's pretty much it. Now, don't worry so much about this tertiary loop over here. For the moment, that's for building on top of the system itself. But let's just pay attention to these two main paths first. So first of all, this path up here, this is for whenever the player enters an action, or let's say the AI decides to do an action. So when the player decides to do an action, obviously we have to type in on the keyboard, right? If we want to do it um, a normal key binding, let's say we bounded a skill to Shift Q, then all we need to do is press Shift Q. So obviously we type in that key binding on the keyboard. There's a function inside the player character which then takes the key binding related to that, gets the action of that keybind, and then we send it over to the animation blueprint. By the way, these boxes indicate like pretty much large code chunks, uh, and therefore the animation blueprint is inside the player character, but the information has to be passed to the animation blueprint first because the player character has a reference to the animation blueprint and not the animation blueprint itself. Okay, so we get the key binded action, and then we set the current action string as that action. Okay? Now, in the animation blueprint, we have this loop that gets updated every single tick of the game called update animation states. Pretty much what it does is there's various booleans in the animation blueprint that are updated in order to indicate whether a skill or a CC or um, a particular action is being done. And the animation blueprint is actually optimized by Unreal to take in booleans um, as the most efficient way of doing state transitions. So going from one state to another state is pretty much the best way to do it is by doing boolean, is by using booleans for the state. So we have to update these states, these transition states, or these transition booleans using pretty much an infinite loop over here. So once this current action string is set, then the current action string is what is being checked every time this animation state is being updated. So once it sees that the animation state is the current action is no longer none, then it will update the animation state booleans based upon that. Okay? And then once the animation states are obviously animation state booleans are updated correctly, then obviously the state machine will transition to the correct state of the animation corresponding to the current action. So in this case, it would be most likely a skill. Let's say it's like Sky Strike. You triggered the key binding for Sky Strike. It got the keybind action name Sky Strike um, as a string. It set this current action string as Sky Strike. Um, the update animation states based on current action detected that the current action string is no longer none. It sees that it is Sky Strike, and then it sets the is using Sky Strike boolean to true, and the animation state machine then transitions to the Sky Strike um, state on the state machine, and once it enters that state, it triggers the initialization values for using the initialization functions for using a skill, for example, consuming MP and putting the skill on cooldown. Then obviously it starts running through the animation that's of that skill. Okay, so that's pretty much how it works. That's one loop. Now, the alternative way of going through that loop is if you used a keyboard text input. So in this case, currently the system is supposed to parse the text that you input in a way so that it can detect whether or not you are simply inputting an action or inputting a command, the is command, or you're defining a new action. Okay, we will get to this part later. So let's just go with the simpler part of just inputting a command. So let's just say you type in, let's use the Skystrike example again. Let's say you type in Skystrike as text. If you start typing in Skystrike, then on your HUD, there's going to be a bunch of autocomplete options once you start type in S, and then K will probably limit it only to Skystrike. And then you can move the arrow keys obviously to choose between the different options, and then you press enter on the option that you like. And let's say Skystrike appears, then you press enter, and then Skystrike is once you press enter, Skystrike will appear in the input line. Once it appears, it would be parsed. Currently, we do not have parsing feature at the moment, so currently it just immediately skips the command. So it takes Skystrike, and then it gets the character that this action is supposed to be that that it gets the character that's supposed to be doing this action. But since we had no name in front of it of the character, then we automatically do it ourselves. Our own character is doing the action. Okay? And then we get the animation blueprint, and we set the current action as the current action string once again. So Skystrike um, itself is the current action, and therefore we're setting it as the current action string as Skystrike. Okay? And then once again go through that um, update and then uh, start animation just like before. Okay? So that's pretty much how input works. Now if you have an AI in here, then you have the AI have its own decision making and then choosing which action to do, and then obviously setting the action as the current action string, and then once again um, update, initialize skill functions, and then start animation. Okay, same thing. Now, after a skill is used, obviously it can damage other characters. So this is why there's a line that connects it all the way out here, even though this is technically from an outside stimulus, in a sense. So this entire loop is assuming that you are being hit by another player character, pretty much, and that's why it's coming from the outside. So once a character does an animation, obviously it creates an attack. Okay, the attack can have CC, it can have no CC, it could be a buff, it could be um, an area of effect attack or something, or anything pretty much. So what happens is once that attack comes in, and we're assuming that this attack is going to hit the character, because obviously if it doesn't hit the character, then nothing happens. Then we do hit detection. You might be wondering, wait, if the attack is definitely going to hit, why do we need to do hit detection? Well, hit detection is there so that, obviously, so we can know when the character is being hit. And second is sometimes when, let's say, especially with melee weapons, if you hit a character with a melee weapon, especially if it's like a slash, it might penetrate, it might cut through, like, let's say the arm, and then it cuts through the torso, and then cuts through the arm again. So even though it's one hit for the skill, it's technically being detected 3 times. So hit detection is pretty much creating a hit table, so that you only get hit by the same stage of your attack um, once during one cooldown cycle. Okay? By one target. You're only getting hit by the same target with the same skill, with the same skill stage, once during that skill's cooldown cycle. Why do I say so many things like skill stages and such? Is because you have skills that hit multiple times. For example, like double stab, 100 Dragon Meteor Strike. Double stab hits twice, 100 Dragon Meteor Strike hits 4 times. And therefore, each one of those times you hit is a different skill stage. So obviously you can hit once every single stage, but you cannot hit multiple times during a single stage. And that's why hit detection pretty much checks if you're getting hit by the same skill by the same character in the same skill stage during one cooldown duration. Okay, once a hit is detected, then we update the interaction targets for both the source and the target. So this is pretty much more in line with in a sense, every time you hit a target, you keep track of what the last thing you hit was. Okay? And also, once you hit that target, um, the, the target also keeps tracks of the person who hit it, effectively. This is very important later on for like CCs that cause two characters to interact with each other. For example, let's say you grab a character. Obviously, it's important to keep track of when the grab stops. So you want to keep track of who are you interacting with, and to be able to cancel the interaction once the grab is done. And that's why there's an interaction target for both the source, or interaction target array for both the source and the source of the skill and the target of the skill. Once the interaction targets are updated, then we check to see if the character that's the target can currently be CC'd. Because, for example, if you use a power move, or a power move is a move that has super armor, or you use a guard ability, you can block the CCs pretty much. Um, and if the character's obviously in one of those two states, they will not go through that transition. If they don't go through that transition, then they won't get CC'd and they won't get affected at all, besides losing a little bit of damage, or losing a little bit of health due to the damage of the skill. Okay? And if they can be CC, then we actually set the name of the CC itself, the string, the CC name string, as the current action string as well. So this is the thing that's probably a little bit surprising, is that the CC is not necessarily a state that you just keep track of, but more of um, an action itself that the character is doing. Because our current action string system is based on each of the animation states, and obviously when you're CC'd, you go into an animation transition, right? So that's why you set the CC as the current um, action string, and then once again, the update animation states checks that looks like the current action has changed and is no longer none and is a CC. So it will update the animation state booleans based on that change. And then the animations will then there should be another thing over here, which is it updates the oh yeah, no, after the animation state booleans are updated, then it goes through it goes into that CC state. And once it enters that CC state, just like this entering a skill animation state, it triggers an animation notify that initializes values for that CC. For example, starts the timer of that CC if it's a duration CC. And and other things. For example, like setting if a if a skill immediately, let's say, grabs a target, then it would set the grabbing to be true. Is grab to be true for the enemy target, for example. Um, or actually, that's a very bad example. Forget about that. And once the CC initialization functions are done, then it obviously goes through the animation itself, and once the animation is done, then it returns to the idle state, just like before. Once the animation for the skill is done, they also return to the idle state. Okay? Once it returns to the idle state, the current action gets set to none, and all of the animation state booleans and CC state booleans are all set to false. Okay? And that's pretty much how these main two loops work. So quick overview again. You input raw text. This gets auto-completed into the action. And then the action is then set as the current action string. The animation state booleans get updated as a result of the current action string being changed. The start skill animation the state machine moves to the associated skill state using the animation state booleans. Then the animation initialization functions start, or the skill initialization functions start, and then the animation goes through, and then and then once the skill is done, the animation state booleans are reset, and that's it. If an attack goes through and hits another player character, then hit detection is there to make sure that the enemy is only hit by the same skill from the same target in the same skill stage once during that skill's cooldown duration. It updates the interaction targets for both the source and the target. The target is checked to see if it's possible to be CC'd at the moment. If it is, then it sets the name of the CC as the current action string. The state machine then moves on to the CC state according to the animation state boolean that have been updated due to the change of the current action string. The CC initialization functions are run, the CC animation runs, and then once the CC animation is done, then all the animation states are once again reset, and that's pretty much it. Now, there's one other thing called an advanced action over here. And pretty much what that is, this is not fully functional yet, but this is the system that's going to be used so that you can define like kind of a training routine in the sense like you want the the enemy character to do a certain set of moves one after another, and you want to constantly practice against that move set effectively. Okay, so an advanced action is something along the lines of, for what I'm thinking right now in terms of your input is you say this and you type in enter and then you input a certain set of moves one after another. Okay, and every time you input one of those moves, whether it be through just like key bindings or by just typing the names out, they will be added to something called an advanced action. An advanced action is pretty much just um, a name string, the name of the advanced action, and then an array of other strings. And each of those strings are actions that actually exist, the names of those actions. Okay? And therefore, when you go all the way over here and says is action queue empty, pretty much you also have an action queue, which is just a literal array of strings itself. And so, but these strings are obviously all valid action name strings. And so once you define a new advanced action and let's say you create a key binding for this new advanced actions, let's say in the key binding menu, and you activate this advanced action. Let's say you can call it like combo 1, for example. So let's say you either type in combo 1 on the input line or you create a keybind for it and you enter that keybind on your keyboard. Then all of a sudden the advanced action gets added to the uh, action queue. So obviously, when the animation blueprint is when no other actions are being implemented, it checks it sees that it's in this state right here, this hexagon state where nothing is happening because everything starts over here, and it sees that there is the action queue is not empty because you've inputted an advanced action which then added all of its component action strings to the action queue. And if it's not empty, then it sets the first action in the queue as the current action, which then obviously updates the animation states based on the current action. And then the skill animation gets the state machine moves to the associated skill state machine node. Once again, it initializes the skill functions, the start skill functions, does the animation, and then once again it returns back to resetting all the animation states once it's done. Then obviously it goes to the next um, action in the queue until the queue is done, over and over and over again. So this is what allows you to do multiple moves one after another, one after another, one after another. Okay? And that's the entire system that I came up with so far. And this is pretty much what I want to ask you guys. What do you think about this system? Do you feel like this system could be optimized any further? I would definitely like to see what you guys have to say about this. And I think that is pretty much it. So thank you guys for listening, and if you have any questions, feel free to ask.